Hi, my name is Riley Cox, and this is my project on bridges. We need bridges because they help us get across bodies of water or crossing a canyon. Other people must walk across the bridge every day to get from one building to another. The basic types of bridges are beam, arched, and suspension. Beam bridges are the weakest and have the shortest span between piers. The span is how long the bridge is between the two piers. The piers are two vertical supports that hold up the bridge. It displaces force from weaker areas to stronger areas. A truss can be added to a beam bridge to spread out force. Arch bridges dissipate force over a wide area so that no one spot must have a lot of force on it. In a suspension bridge, the roadway hangs from cables that are firmly anchored down on either side of the span. Tension is given to cables and compression is given to a set of towers that are put firmly in the earth. Some other types of bridges are truss. Another beam bridge is the truss. It's made up of many small beams joined together to form a framework of rigid triangles, or a shape that resists being distorted by stress. Trusses use relatively small amounts of material to support relatively large weights. A cantilever is a beam that's supported only at one end that extends beyond its support, like a diving board. Sometimes two cantilever arms meet at mid-span. Cable-stayed bridge. Like a suspension bridge, a cable-stayed bridge supports the main span using towers and many strong steel cables. In a cable-stayed bridge, however, nearly straight diagonal cables stretch from the towers to the roadway. There are no anchorages to help support the load. I'm making a truss bridge. This is the side view over here with the measurements, and this is the bottom view. I use jumbo popsicle sticks, wood glue, binder clips, hand saw with parent assistance, and sandpaper blocks. Over here's my weight test, and I'm using heavy plates. This is a level over here. That's my bridge, and these are what I'm going to use as piers, which those are sawhorses. Triangular supports in a truss dissipate force. It's made up of many small beams joined together to form a framework of rigid triangles, or a shape that resists being distorted by stress. Trusses use relatively small amounts of material to support relatively large weights. And I'm so surprised how much it held up at that point. Now, my hypothesis and data collection. I think my bridge will hold 45 pounds. My bridge actually held 185 pounds, and it crashed over there. And this is proof that it crashed. Tension and compression went mostly over here, and that's mostly where it broke.